Irene, you just tell me when to get started. If we have to wait a little bit and wait for people to join, you just let me know when to start.
Okay, no problem. Now it's on my laptop is 7:57. So when it's 8, then we can start. And you know, WhiteMatrix is preparing some certificates and to the speakers as well, not only the attendance certificate.
Yeah, actually, we prepare some certificate and we will mint them on the blockchain, and everyone can own the kind of NFT when they finish their presentations. And for all the students who attend into the class, they will also get the souvenir.
Yeah, that's wonderful. That's just wonderful.
So is the souvenir a secret now?
I'm not sure, but I think maybe some of us we have already told that. Yeah.
Actually, in this seminar, a lot of U of A alumni, including some speakers as well.
Yeah. We invite some guests from our Department of Computer Science also, such as Aaron Liu. He is in Best Buy now, but he also graduated from the University of Alberta and the Department of Computer Science. He's also our good friend. Yeah.
Oh, that's great. Yeah, that's wonderful.
Yeah.
And I think he graduated about 10 years ago, is it right?
Yeah, about 10 years ago. He's a genius coder, I mean. He usually work for BlackBerry and also Frostbite. Yeah.
Actually, relating to blockchain is still quite new. And I'm not sure in computing science, any, any lecture relating to that. I haven't seen any. Yeah, now you can see Anoop, not only the background. Anoop.
Hi. Nice to see you.
Hi.
So you just finished the other meeting, right?
Yeah.
We have 1 more minute. Okay, I think we can start. So good morning and good evening, because we have participants from different time zones, right? So I don't know how many time zones are joining here, but it is exciting to see high participation. You cannot tell from the number on the screen because there are participants in China joining using a different webcast. So I think to avoid interference, everyone is mute. So I think that's good. So this blockchain and multimedia data science seminar has a 4-day program, including keynotes, research talks, panel discussion, and student project competition. So this is the first event that the Multimedia Research Group at the University of Alberta collaborates with WhiteMatrix. The CEO of WhiteMatrix will tell you more about the company, but now I have the honor to invite the Dean of the Faculty of Science at the University of Alberta to kick off this event by delivering an opening speech. So Dr. Matina is an internationally recognized scientist. Her research focused on the biology of acoustic communication in bats and mice. But today she is not going to talk about bats and mice. So let us welcome our Dean of the Faculty of Science.
Thank you, Irene. Well, good morning, good evening, good day to all of you. I hope that this message and my coming to you finds you doing well through the pandemic. I am delighted to be joining you tonight, and in Edmonton, I'll say tonight. On behalf of the Faculty of Science, it is my pleasure to welcome you to kick off the Blockchain and Multimedia Data Science Seminar. So, as you just heard, my name is Matina Kalkunis-Rupel, and I have the privilege of leading the University of Alberta's Faculty of Science, and I'm the Dean of Science. Before we get started, I'd like to acknowledge that the University of Alberta, and where I am sitting here coming to you now, is a location of Treaty 6 territory, and this is the traditional lands of First Nation and Métis people. The University of Alberta respects this land and continues to be enriched by the First Peoples of Treaty 6 territory and these First Peoples of Canada. So I want to start out just with some context about the Department of Computing Science and just a little bit of history. The University of Alberta's Department of Computing Science has earned an international reputation for its excellence in teaching and research. This department was founded in 1964, and it is one of the oldest and largest departments of its kind in Canada. In fact, I learned not too long ago on April 1st that the Department of Computing Science celebrated its 57th anniversary. This is a department with excellence in many fields of computing, including artificial intelligence and machine learning, among other disciplines. And each of these fields has the goal of addressing some of society's biggest challenges, and certainly blockchain technology is no exception. From cryptocurrency to applications in finance and healthcare, blockchain technology has the potential to revolutionize the way we think about data security and the way we think about privacy. I am really happy to see this remarkable lineup of experts in the field that will be joining us for this seminar over the next few days. I'd like to take a moment and acknowledge and thank the organizers of the seminar. Irene Chang is an adjunct professor and director of the Multimedia Master's Program in the Faculty of Science, and I can't say enough about her mentorship and innovative teaching practices that pair our graduate students with industry partners to create experiential learning opportunities and what are really mutually beneficial partnerships. It's a program that we're very proud of at the University of Alberta and in the Faculty of Science, and it exemplifies authentic experiences for students, which we want to give to all of our students. And this is also a very foundational type of work integrated learning for students. Irene, I want to thank you for all that you do and for all of your hard work in developing this seminar. Thank you.
Thank you, Martina.
I'd also like to thank and welcome Xiao and Tim Zhang, Xiao Wu and Tim Zhang. Xiao and Tim are the co-founders of WhiteMatrix, a technology company focused on development and research in the blockchain ecosystem. WhiteMatrix is at the cutting edge of this field of research and is rapidly expanding its operations in Canada. I have to say that I'm also very proud of and excited for WhiteMatrix and the work of Tim and Xiao. They are also alumni of the Computing Science Department twice over and support the Faculty of Science through their kind philanthropic work. This pair embodies the entrepreneurial spirit that is shaping the future of our world. So thank you, Tim, and thank you, Xiao.
Thank you.
Yep, you're welcome. Industry collaborations such as this partnership with WhiteMatrix are part of what make the University of Alberta an incredible place to work, study, and do research. I'm not sure if you saw any of the news today, but the University of Alberta's rankings came out in terms of our research and impact. And these were really impressive rankings today. And it's through research and partnerships like this that we have the reputation that we have. These kinds of partnerships create invaluable learning experiences for our students, and these are real experiences that change the career trajectories of our students and make differences in our worlds. These experiences supply cutting-edge research and innovative ideas also for industry. And we are delighted by this partnership with WhiteMatrix, and I am grateful for the support of WhiteMatrix to the Faculty of Science. So again, welcome to your seminar. I'm delighted to be joining you. Thank you. And it's now my pleasure to introduce Xiao Wu, the CEO and co-founder of WhiteMatrix and a Faculty of Science alumnus. Thank you very much.
Thank you, thank you. So maybe I can give my opening speech. So hello everyone, welcome to the Blockchain and Multimedia Data Science Seminar. My name is Wu Xiao. You can also call me Ling, which is my developer name. I'm the CEO of WhiteMatrix. WhiteMatrix is a technology company specialized in research and development of blockchain middleware technology and a global developer ecosystem. It is a great honor to co-host this online seminar with our friends from University of Alberta Multimedia Master Program. Our CTO, Shuyi, and I are both alumni of the University of Alberta. I received my master and bachelor degrees from U of A in 2015 and 2013, respectively. I'm proud to be a UA student. I still remember my first day come to Edmonton. I remember the days when I live in the hub, study in the Cameron Library, and code in Computer Science Center. It is great that we still keep a strong connection with the University of Alberta. I first want to thank to our Dean, Dr. Matina Rupal, and Dr. Irene Chang, and all our friends from Multimedia Master Program for your help in this event. Without you, we can never host this Canada Pacific Joint Seminar. I also want to thank all the friends from blockchain, multimedia, or data science area. We gather here to learn, to think, and to share knowledge. Blockchain is a heating topic over the last 10 years. We see great potential in blockchain technology to reconstruct the world economy. On the other hand, data science is also continuously expanding in recent years. Both blockchain and data science transform how businesses are operating. While data science extracts valuable information from structured and unstructured data and make predictions, blockchain ensures data integrity and use smart contracts to define regulations. As Dr. Irene mentioned on the homepage, together both technologies safeguard information trustworthiness. In this seminar program, we invite guests from both academic and industry areas. We hope to provide an insightful seminar in the next following 3 days. I hope you all enjoy this program. And
thank you
very much. Yeah.
So let's see. Now, our next session will be from the CTO of WhiteMatrix. And before that, if the audience, if you want to ask anything or comment, and you can use the, so there's one, the raise hand option. If you want to comment or say anything, you can use the raise hand option. And but when we see that, we will invite you to unmute your mic. Let me check. Okay, so far I can't see any hands. Probably now I invite the CTO of WhiteMatrix to continue the next session.
Sure, sure.
Thanks, Professor Cheng. Dr. Matina and Xiao. So thanks for providing this kind of inspiring and I would say very emotional like talk, because we are all like alumni of the UFA. So I will be I'm actually very honored and proud of like be part of this great university. So here I'm here just taking over this this presentation to let's go to this next section, which is the start of all these 3 days talk. So my presentation will be introduction to blockchain. So let me share the screen first.
So to the audience, if you have questions about this introduction to blockchain, at the end of the talk, we will have time for your question.
Can everybody see my screen?
Yes.
Cool.
Yeah.
All right, so let me do a brief like introduction of myself. So my name is Shuyi Zhang, so you can also call me Tim. So I'm the CTO of WhiteMatrix, and today I'm also like the alumni of University of Alberta. Today I'm very like proud of like being a speaker, at least the first speaker here. My talk will be introduction to blockchain, and also want to like give some insights of like how blockchain will interact with like data science. We'll do the next slides. So here are the contents of the my talk. So my talk will divide it into like 4 different sections. So section 1 will be the introduction of blockchain technology, and the section 2 will be the blockchain innovations today. Section 3, it will be the very interesting section that I want to give some insights on like how blockchain and the data science will act when they meet each other, and what is the future potential. And the section 4 will be the section for like question and answers. One second. Sorry, there was something happened.
Yeah, the slides disappear.
Slide disappears. So, one second.
You need any help? Maybe.
Should be good. All right, so figured out. Okay. One second. Can you see it? Can you see it?
Yeah, yeah, it can.
Okay, okay.
Yeah.
Finally figured out that there was some issue with the slideshow.
But this is the presenter view, not the.
Is there any way that I can convert back to this?
Let me see. Are you using a multiple display?
No, just one display.
Okay.
Let me redo it. Sorry for the issue. So
Don't worry, Tim. It happens to all of us.
you can see it here.
Yeah, it's perfect.
Yeah, it's
Okay,
good. Yeah.
it's much
Ah,
better.
it's perfect.
Okay. All right, so the first section is like the blockchain introduction. So when we talk about like blockchain, we always like refers to two different meanings. So one is the original meaning, right? So in the original meaning, we always refer blockchain to a data structure technology, which is namely a blockchain is a growing list of records called blocks, and that are linked use cryptography. Each block contains a cryptographic hash of this previous block. Generally, it's a timestamp, but sometimes it can also be a number, right? And the transaction data generally present in a Merkle tree by design. A blockchain is resistant to modification of its data. This is because once recorded data in any given block cannot be altered retroactively without like altering all the subsequent block, which this actually like gives the characteristics of blockchain that in data integrity, continuity, immutability, and traceability. So, but currently what we are more familiar with is the current meaning, that is a distributed ledger. When we talk about like blockchain, we always talk about like Bitcoin, like Ethereum. So these are all distributed ledgers. So that is generally managed by peer-to-peer network, collectively adhering a protocol for internode communication and validating new blocks. So although blockchain records are not like unalterable, but blockchain may be considered secure by design and exemplify a distributed computing system with high like Byzantine fault tolerance, which means that it's not 100% immutable, but you need to pay very high price to like do a hack or like alter data in the system. So blockchain has been described as an open distributed ledger that can record transactions between two parties efficiently in a verifiable and permanent way. So this is how like blockchain create the trust between parties. So we can see, so this is the underlying data structure of the blockchain, and on the bottom, this is how the blockchain network built on top of this data structure. So let's talk about the characteristics of a blockchain. So when we talk about these like data structures characteristics, so we often refer to immutability, which means that the blockchain contents cannot be altered when it is recorded, right? And the second part is cryptographic verifiable, which means that all this data is encrypted in a way that it can be verified cryptographic way. The third one is traceability. So which means that for a history of the transaction, we can always like trace it back to the very beginning state. And the last one is data integrity. So this data integrity means that the data is complete, continuous, and can be checked and trusted by others later. When a data structure has these four very important characteristics, we can actually build on top of it to provide more derived characteristics, and we call derived features that empower the whole network system. So the first one is permissionless, because the trust and the cryptographic verifiability is assured by this underlying data structure. So we don't need everyone can attend into this network without any permission, because all these transactions can only be signed by the owner of the private key, and it can only be verified in a encrypted and a cryptographic way. The second one is decentralization. So which means that every peer, every node in this network, they are equal. So there's no like centralized authority. The third one is trustable. Trustable means that we already have this data integrity permissionless, and also this data integrity permissionless and the privacy ensured by this characteristics above, so we can trust each other easily because of the underlying design. And the last one is consensus. So this is actually very very related to the decentralization, means that each node in this network will share the same view of the world, right? So there's no like centralized authority. Okay, so how is blockchain evolved and introduced into this into current like financial world, right? It begins with a the start begins with rebuilding the financial system today. So imagine a day where there's no bank, right? So how will we like create an alternative to the current banking system? Can we invent a better system, right? So this is basically the problem statement, but what is the real problem? Okay, so the real problem of like current banking system has these four, major shortcomings. So first one is high transaction fees. So to make up a bank, right? So we need to make sure the asset is correct and the funds are safe and the ledger is like audited correctly. So and also the bank need to hire people to serve the clients. So all these will require money to maintain the operation of bank. So obviously for each transaction, we need some like service fee. So that's a transaction. And also the trust expense, the trust costs are very high because in the centralized world, all these operations behind the bank is invisible. So we don't know like what is bank doing with our funds, and also bank don't trust us in another way because bank is always considering there might be a fraud or attack in these transactions. So it's very hard and very expensive to create the trust relationship between the clients and the bank, and also between each banks, right? So there's also very high trust costs because they have different banking system and the data scheme. So that leads to the third problem, which is inefficiency. So when we try to do some like cross-bank payments or transfer, the cost to create the trust and also make sure the data scheme is like a clear laid out is very expensive. So that's why when we do a wire transfer internationally, we always need to wait a few days, right? The fourth one is risk of centralized storage. So centralized storage typically means that when a bank holds your funds, right? So a lot of people in this bank will have access to these funds, right? Because they need this data to do these operations, and it causes a single point of failure in this transfer or like transaction chain. So if we do a interbank transaction, any operation or any like actor in this processing chain do some bad thing to the funds, or there's any like operation will cause like money loss. So here is the very initial like proposal of the current blockchain network, which originated from 2008. So the paper written from Satoshi Nakamoto. So even until now, we are agnostic. We are agnostic of like the real identity of Satoshi Nakamoto, but this paper is very evolutionary. So I highlight this sentence. It's actually the first sentence in this abstract. A purely peer-to-peer version of electronic cash would allow online payments to be sent directly from one party to another party without through a financial institution. So it has a lot of information here. So the first is it's a peer-to-peer network. So that's basically the network structure of current blockchain system, and also it's a payment system, which means that it will have we will have like ability to do like financial transfer in this network. So that's basically the idea of behind the Bitcoin. So Bitcoin is a payment currency. And also the third one is directly, right? Because it's peer-to-peer, so we don't need to go through the middleman or like an authority. So we only rely on the predefined business logic, namely code written into this network system to make sure there's no problem caused like double spending or like fraud in this network. So this is how a transaction being flowed in this blockchain network, Bitcoin network. So someone requests a transaction and the transaction is broadcasted to this peer-to-peer network. So in this network, each peer they are equal, so they can do the same thing. They can all submit the transaction and validate the other's transaction. So when a transaction is sent to a network, the validation process begins and we validate, oh, this transaction is correct. There's no double spending, there's no fraud. So once it's verified, the transaction become a part of new block and added to the ledger. Once it's written to the ledger, right? So it will be very hard to be reverted, to be altered, to be like changed. And then the transaction is complete. Once it's complete, it means that in the world view, in the like distributed ledger, every node will receive, okay, this transaction is done. So every node will keep, all the nodes keep the same consensus. All right. So here are four different shortcomings of the current electronic financial system. The first one is centralized storage. The second one is private ledger. Third one is prone hack. The fourth one is double spending. Centralized storage, as we explained in the previous slides, which means that the ledger is only stored in one like organization or one authority. There's chances of like single point of failure. So how to address this? So blockchain basically use distributed and decentralized ledger. So which means that every node in this network will share the same ledger. And if there's anyone in this node, in any nodes in this network will do anything bad or like make a fraud transaction, which will conflict with all other people's ledger. So this actually eliminates the possibility of single point of failure. So the second one is basically this is very important to the later ecosystem of all the blockchain development that is the public ledgers, which means that all the ledgers information is public to everybody. So all the people can view what is happening in this blockchain, in the blockchain network. And also it allows people to attend into this network without any permission because there's no permission to data. The third one is immutable to hacks. So by design, blockchain is immutable to hack because the chain data structure, we already mentioned before that when a fraud happened, right? So it will be impossible to alter it once the blockchain is already written to the ledger because it will break the chain. Any fraud will cause a new hash, and that hash will not match will not match against the previous node and the next node. And also during the transaction, if there's a bad data or a fraud transaction, it will violate the distributed ledger consensus. So all these other nodes with the correct ledger number will reject that transaction. The last one is double spending. So double spending, double spending actually is already like included in this third section, immutable to hacks, right? So when there's anything that is that is wrongly calculated, for example, double spending, right? So we spend the amount twice, then every validator all the validator will find, okay, this is a mistake, or this is a transient problem. So the only chance that double spending happen in this system is that every validator will make the same mistake. So that's almost impossible. All right, so this is how basically this is how Bitcoin solved this problem of electronic payment system. So, and also I want to summarize, there are some innovations of Bitcoin. So first one is Bitcoin is the first digital cryptocurrency. So it's not first digital currency, but it's cryptocurrency, which means that it actually the system actually ensured people's data privacy, and also no one can act on behalf of the private key holder because they don't have the private key, right? So that's the benefit of cryptocurrency here. So the second one is also kind of overlap with the first one, is it uses cryptographic encryption method to create and manage accounts, which means that all these, even though we have all this open data on the chain, we can only view the data, but we cannot manage these assets on behalf of these private key holders. The third one is it created a electronic distributed ledger blockchain. So it used blockchain as the underlying data structure as the ledger. And that's why nowadays we usually call Bitcoin blockchain, right? Or the very first blockchain. So this is the major reason. And also this architecture is inherited by all the followers like Ethereum and Polkadot. The last one is the ledger bookkeeping is updated by everyone solving the mathematical problems. So this is basically very back then very innovative idea, is that how we make sure there's a cost when we try to keep the network in sync, right? So this is also namely we call it POW, but there are now more innovative consensus algorithm like POS, the proof of stake, right? So this is this one is called proof of work. So you need to do some work to show the whole network that you're validating this new blocks. Okay. So how is blockchain evolved into the next stage? So here is what happened. I think it was 5 years ago. So we already have this validation processing or validation power in this Bitcoin structure. So this is actually equivalent to decentralized computation, right? Even though it can only run predefined programs. And the second one is we already have this P2P trading or payment system. So it already have this the capability for any people on this platform to do online payments, and also the system itself has an incentive mechanism to reward these people. So if we combine these two together, so what will we get, right? So it's decentralized computation and the online payments. So it will become a decentralized payable computation engine. So it's very similar to current cloud service platform, which is you pay the service you use in the cloud and you get this computation power. But this is in a decentralized fashion. Okay. So this is the transition from P2P payments to cloud computation. So what is beyond the financial transaction, right? So we actually get the next step we wanted to involve it, which is decentralized P2P transaction and computation engine platform. So these two features will make the blockchain network programmable and extensible. And now most blockchain we know are all programmable blockchain networks. So for example, Ethereum, like Binance Smart Chain and Polkadot. And the Ethereum is actually the one that proposed this idea, first proposed this idea. So we can see in this graph that on the Bitcoin network, there are only like currency or like payments or transactions, financial transactions here, but on the Ethereum network, we have much more capability to do more like complicated application, including like more complicated financial application. Okay, so Ethereum is an open source public blockchain-based distributed computing platform. This is cited from like Ethereum white paper. So they don't call themselves a like P2P payment network. They call themselves distributed computing platform. And the most important feature they invented is the smart contract, which gives any people the ability to use the blockchain network to do customized scripting and computation. And the smart contracts are runnable on the blockchain network. So here we can see, so smart contract has these features, that is, it actually extends the feature of Cody's law, but make it more useful for the public. You can define your own law on this blockchain as long as like people agree with it. And also this is trustless execution, which means that you don't need to get any permission to run the chain as long as you agree to attend the network and agree on the agreements of the network. And also there are default backup and avoid manual error. So basically these are automated computations, so there's no manual step there. Okay. So applications developers now with Ethereum can like upload their programs into this canonical virtual machine. So in blockchain, we always like have a vault-view ledger, but it's not programmable. But in Ethereum, we will have a canonical virtual machine, which is similar, that keeps the view of the data across the network, but also keeps the same mechanism of do the computation. So that's why it's canonical virtual machine. And all users on the blockchain network can execute functions of those programs. So we can see this comparison between like a Bitcoin layered structure and the Ethereum layered structure. So Bitcoin is is actually the very first generation of blockchain network, and it did the most important, very important like innovations like ledger storage, execution, consensus, peer-to-peer network. But Ethereum, they only added a very small functional component here, which is the smart contract. But it is a small step in blockchain, but a big step for all these developers. Okay, so now we can see how important is this big step. So we have people can develop games and develop financial systems, sharing the arts, and also doing the supply chain management on this Ethereum platform. But for Bitcoin, we usually only do the like financial transfers. Okay, so here are the new applications we introduce, new generation of applications that is introduced by Ethereum, which is called like decentralized app. These apps are applications backended by smart contract, and anyone can deploy a set of functions that is smart contract. So nowadays the range of the decentralized applications ranges from marketplace, financial instrument, IoT management service, games, big data, and data science, and potentially like anything you can build with like cloud computation technology. Okay, so the second section is basically, I want to cover a little bit about current blockchain innovations today, namely like decentralized apps. Okay, so I want to divide the blockchain innovations into two parts. So the first part is the information synchronization across trust subjects. So they solve this problem. And the second one is more about like the blockchain native innovation, which is that a problem that exists that can only be solved by blockchain. So let's go through these two categories one by one. So the first category, the very beginning example is the judicial evidence. So that is, the problem is that when we try to do a like a judicial evidence or maybe a notary, when we try to do a notary, so it will be very complicated that we need to provide all this evidence to different trust subjects. So we need to provide evidence to the notary office and provide evidence to the court, and it will have a lot of like trust cost. But once we deploy all these business logic onto the blockchain, we only need to use a smart contract to do the evidence upload, and the other node in this network, which is namely the notary office node, will also like execute another smart contract to validate and provide the evidence, or maybe provide the proof of the evidence of these uploads. And the third node, which is namely the internet court, will accept the evidence provided by the smart contract. So it will save a lot of like trust cost and communication cost, and shorten the time of a judicial evidence from like months to days. So nowadays in China, we already have like Beijing and Hangzhou internet courts that serve this problem, and the underlying technology they use is blockchain. And the second application I want to talk about is the medical traceability and the permission management. So the problem is that there are some people, maybe rich people in poor area, need to transfer the treatment, right? And they don't want people to access their data, right? They don't want random people to access data. But when in a traditional way, when you do this transfer, treatment transfer, a lot of people will access the data in this operation chain, right? So blockchain provided a trustable way to transfer your treatment from area to area. So because these rich people, they are holding their private keys, right? So they can assign like which people or maybe which doctor can access like their own like private treatment data. So this all these like data access and data access management and medical treatment transfer will happen on the blockchain smart contract. So the Alliance chain is pulled up by the UN Department of Health, and nowadays people can use this Alliance chain to transfer their treatment and do the permission management on the chain. So there's a very interesting trend we observed today that basically the Alliance chain, or maybe we call it a consortium chain, technically is very similar to the public chain we see that is Ethereum and like Polkadot, but the ecosystem and the applications built on top of these two types of blockchains are very different. So we see the two previous examples that applications built on the consortium chain basically leverage blockchain to do the cross-subject data sharing and the permission management. But on the public chain, because it's permissionless, it's 100% open, so people are leverage the permissionless and the trust between like all these public people. They are building up different applications, and that leads to a cognitive decoupling. So nowadays we only see like technical decoupling, but gradually the cognitive decoupling may happen if the technical decoupling takes very long. So here are two applications I want to share on this public blockchains. So the first one is like Compound, the second one is called Uniswap. So it's very hard to know what are these applications just purely from the name, but I will go through them one by one. So Compound, which basically is a bank on the blockchain, and it's more like an international central bank rather than a local bank, because on the public blockchain, people are from like all over the world, right? So which means that if we build a financial institute on this blockchain, it can leverage its like the characteristics of permissionless, public, and the global internet connectivity. So we already observed that there are already $10 billion being like staked in this bank, and people can everyday people can like borrow and stake money in this centralized bank. So why this? So Compound is actually one of the first like decentralized financial application on the public blockchain, but we already know that this kind of applications will eventually happen. Maybe it's not Compound, but someone else will invent it, because there is a huge demand of like financial asset management on the blockchain, because when people buying like cryptocurrencies, people will put the money into the blockchain network, and it will usually like there's restrictions of like withdraw money from network. So there's a demand of like, okay, I want to do some like asset management, and also I want to do some like investment on the chain. So that's why the bank is here. It's basically a map of the real world bank into a blockchain network, which is a digital world, but with a different way. That is, this is fully automated and without any human effort there. So all these like banking and lending logic is actually scripted in the smart contract. And Uniswap is another innovative application on the blockchain, and it's actually Compound is a central bank on the blockchain, and the Uniswap is basically the exchange on the blockchain. So we before this like decentralized exchange happened, so we usually like exchange the cryptocurrencies on the centralized like exchange. But there are a few like drawbacks of centralized exchange, that there are a lot of like manual steps still, manual efforts still. When we try to when we want to like list a asset we want to exchange, we need to go through very complicated human step and like manual review. But Uniswap with a design of AMM, like which enable like any anonymous person on the blockchain can provide the liquidity and also list the asset they want to trade. So this is very unique and innovative, that there's no bar for people to like list their asset, and it already and this already like accumulated billions of dollars market cap nowadays. And we all know like last year, which is the we call a year of like decentralized finance, and it's typically like led by Uniswap. So let's take a look at the different stages of the financial system. So the first stage, which we call state 1.0, is like a traditional bank, right? So we actually like lease business premises, hiring personnel, and observe saving and lending. So these are all like manual steps. So the second stage, which we call internet bank, right? So which is we migrate part of the logic from manual like SOP into like programs, but it's also centralized and also limited to offer very limited access to specific people to access, because there's also very high risk of single point of failure. And because it's internet, there's no real like building or like office there. Very rare people trust it. So that's why like internet bank only offers the service to specific people, like rich people or maybe people restricted to certain areas. But the third stage, like 3.0, which we call decentralized finance, DeFi, is actually like totally leverage the smart contract, which is scripting on the blockchain to do this lending and saving logic. So because the trust is already created by the infrastructure itself, it becomes people don't have like worry of like a single point of failure or like a money loss, as long as the logic is correct. Because we always like insist that the code is law. When there's a loss in the DeFi application, which means that the code has a bug. But if the code is 100% correct, then there's no risk of losing money. So that's why like DeFi observed a lot of money and saving a lot of money and saving in the decentralized world. And also like the geek and the old monies, they step into the blockchain world in a very first like time. So they always like seek decentralized finance to like to do their asset management. All right, so talk a lot about the decentralized finance, but what else like blockchain can do? So blockchain basically not only like the token or maybe the currency we can manipulate in blockchain. We can also map any like real world like asset onto blockchain. So in blockchain there is a term called like non-fungible token, which is different from the fungible token we all know today, like all these like cryptocurrency. Non-fungible token means that that is a asset that is unique on the chain and it cannot be replaced by any other asset. So CryptoKitties is the very first attempt of non-fungible token. So it basically generate the cats from a random number as its gene, and each cat will independently will become a non-fungible token, and it has its own like characteristics based on its gene, like the eye color, the fur color, and also the appearance. And it makes these assets unique and tradable. It's become CryptoKitties become a new like playground of these people, like people who want to like collect assets, these like internet collectors. And also on the right side, which is the first upper, that is a blockchain art. So what is first upper? So which basically is a multi-layered art, multi-layered picture that each layer is owned by a different person, and the person on that layer can design what's the appearance, what's maybe the animation, maybe the sound effect of that layer, and it's a cooperative art. It's a anonymous and cooperative art only can be built on blockchain, and So the main body of the first upper is a master, which is a canvas, and it has like 22 layers. And the 13 artists like collaborate and create this art. So this is a new field of programmable arts being like gradually established by crypto artists. So we observe the trend that a lot of like digital artists are moving to like blockchain network. So because of like they lost like Flash, right? But they find a new like playground that can leverage their skill to build like beautiful arts. And also blockchain games is another area. Basically WhiteMatrix initially like stepped in and did some exploration. So this game is called the Cell Evolution, that is divided into like two parts. So one is pre-chain puzzle, and the other one is on-chain social gameplay. So every player is play as a own cell that try to do different actions like mutation and the split to develop themselves to become a more stronger like group. And when a cell is like entered to a world, they need to like interact with like other player cell to collaborate and cooperate to build the world, to make the world like balanced and successful. So so if there's one player that make very greedy or bad like actions to make the world unbalanced, right? So the other players can also be greedy, but the world will end soon, or they need to like sacrifice and make the world balanced. So all this pre-chain puzzle is like done offline, off-chain. But once they upload this like result on the chain, it becomes a like social game, and the players in this game will share the feeling of achievement of building a successful world. So that, and all these history of world will be permanently recorded on the blockchain. Some other applications which is we think very important is we call it the blockchain midwares. So blockchain midwares, which is basically the connectivity layer between the front end and the blockchain backend. So which means blockchain backend and infrastructure, which means that it is aimed to provide a better accessibility of blockchain. And we made a attempt of which is called Cheng ID, is a cloud-based integrated development environment for smart contract that everybody can can open a browser in any platform and do this blockchain programming, and then upload their program to the blockchain, and basically build their own like blockchain applications. Like we mentioned, the CryptoKitties and also like the decentralized finance can also be built with this tool. And now we already have like more than 100 countries and 3.5 million smart contract compiled. And we also won the first prize of China Blockchain Development Contest in 2020. So do a quick summarize of the blockchain innovations compared to the traditional world. So in the traditional coinage, we have lease, exchange, fund, we have broker, bank, payment, and small loans, and also insurance security. And we all have this, it's like co-parts in the blockchain world, but implemented in a really different, in a very different way. That is, for example, we have like Compound as a bank, right? We have like a Curve, a Uniswap as the like exchange, and we have like the asset management or yield aggregator, which is Wi-Fi, which is similar to the feature and funds in the real world. So, so this is what we call the blockchain native innovations, that you leverage leverage the nature of blockchain to build the applications that can achieve the same effect in the real world in a more efficient, decentralized way. All right, so I think enough talk for the current innovations, and I want to look forward a little bit to talk about what will happen if blockchain meets data science and technology. So this is a a general picture cited from a survey paper. I already have this reference in the end. So it summarizes, okay, so how blockchain technology and data science can meet in a middle ground. So blockchain technology basically it's an infrastructure of data and offer the data storage, data sharing, data validation, integrity, and the data security, right, for the people. And it's open, it's basically open to any people to access. And it also features smart contract to allow the people to do their customized logic and scripting on the blockchain. And the data science, which is more about extract useful features and find the insights in the data to help people to make better decisions. So it covers from data processing, data mining, analytics, machine learning, and decision making. So from the graph, we can see besides blockchain and the data science, or maybe we call artificial intelligence, there's also other areas that will join with these two different technologies, like swarm robots, smart cities, like IoT, and also virtual reality, augmented reality. All right. Okay, so the first type of application we can foresee is applying blockchain to data science field. So basically, blockchain is a trustable and the permission or permissionless data structure, and also infrastructure. We can apply it to data science to provide a better maybe data quality control, data access control, and also validation for the whole data science processing chain. So for example, here is a small proposal I proposed that maybe in the future it can be a research direction, that is when we have a data pipeline which get involved with data producers such as ImageNet, right? So it actually collects data and provide labeling, and also data and Hive, right? So it has a lot of labeler that's doing the data labeling there. So blockchain may be a very good platform for people to share the data they produced. And then the other people, or maybe other subjects, organizations on the chain can become a data processor that they accept the raw data from the data producer and also provided the generated output of the maybe the pre-processed data or maybe the fine processed data, such as machine learning companies, or maybe the data cleaning companies. These companies can all be categorized as data processor, and then the data validator needs to be maybe the authorities or any third party that have the ability to validate the data to make sure that the data generated by the data processor and data producer is correct, or it's there's no fraud data or bad data there. And then once the data is processed and validated, the data consumer can also come to the blockchain and acquire the access from the first three entities. And the data consumer itself can also become the next loop, the data producer in the next loop. So it become a kind of a loop structure that makes sure the data can flow in this structure in a healthy fashion. Another thing we can apply in the blockchain to the data science is we can enhance the data security with blockchain. More specifically, for example, we have these kind of like swarm intelligence or swarm agent, which is controlled by the artificial intelligence. When they collect the data, the blockchain can make sure these data are correct. These data, they don't include any like bad data or maybe like invalid data. And then these data, once this data is validated, these data can be put into the next iteration of like data training and also maybe produced as a result to the data consumer. And we also find another exploration on this like blockchain-based consensus that is a proof of discovery. So each robot in this blockchain network will do this discovery job. And once the discovery job is validated as good, or there's as a new discover, then it will be used as a proof for the blockchain to mine the next block. So this is a very innovative consensus algorithm besides the proof of work and proof of stake. Also, we can also apply data science to blockchain. So this is the reverse way. So, for example, why blockchain is a very good data source or like platform for data science? Because blockchain it is purely open, and all this data is accessible for all the people on the blockchain. So everybody can like attend this like data analytics or data mining job of the blockchain data. So on the left is basically, it's one of the Google's research that they actually dump the Bitcoin data into Google's BigQuery, and then they do a kind of like a data pre-processing and data cleaning, and now it become a BigQuery data set that people can easily query the blockchain data from the BigQuery. On the right side, which is the dashboard that is created by the BigQuery. So the last one we already talked about is another consensus algorithms that is we talked about before. That is the new consensus algorithm. So I won't go through too much details here. And also we applying data science to blockchain, we can train like better like trading agent that do automated like cryptocurrency trading. So what's the next of AI and blockchain? So this is actually the TechMint summarized like 7 essential technologies. So robotic plus blockchain plus AI plus IoT, maybe it's a next generation of swarm intelligence. So blockchain plus AI plus AI and VR, maybe it's next generation of the immersive experience, like the Ready Game 1. It's usually we call it the metaverse. All right, so that's all for my presentation, and thanks for watching. And if you have any questions, you can take time to ask. And I know the time is exceeded a little bit, so sorry about that.
No, actually, it is good because the next session will not start until 9:15. So we have 5 minutes for questions. Okay. So actually, Tim, thank you very much, because a lot of information in your talk. And the good thing is, it's not just science, right? It's art too. It's amazing to hear about your art. I like that picture, the art in different layers. And also about games, and games also can make use of blockchain. Now, for the audience, if you want to ask questions, you have a raise hand icon you can click.
Thanks, Irene. So yeah, so basically blockchain is a like a technique that can apply to different areas and then can combine with different technologies. So yeah, that's the future we are looking forward to.
Yeah, suppose I have a business like e-commerce. I sell sports card now. It's quite popular, like hockey game, baseball, all those sport card, and maybe Pokemon. I have a business like a web application to trade cards. Do you think I can benefit from blockchain? And if so, what do you suggest as the first step?
Oh yeah, so definitely that's a good field for application, good field of application for blockchain to shine, because as we mentioned, that the blockchain has a very good has an advantage that it's purely public and everybody can attend and like purchase as long as they have this access to the blockchain. So it will eliminate it basically like eliminated the step of like you need to like register the I mean the marketplace for your like card trading system. Or usually like if you want to do a like US dollar trading or Canadian dollar trading, you need to like have this kind of certificate to do so. The second is because it's purely open, right? So everybody can contribute to this kind of platform. So I would suggest that leverage the open like blockchain infrastructure, and you only need to do the basic like business logic and smart contract, and also front end. There's no need to do any kind of like server like programming, and make sure the smart contract logic is good to go. Then yeah, that's already a good start. It's also like much quicker than like traditional like application building.
Right, thank you. Now I can see hands. How about Stephen Fan?
Hi team, can you hear me?
Yeah.
Yeah. Thank you team for this presentation. So actually I have a question about the consensus algorithm. So we know that right now we have a lot of choices about the consensus, like POW, PS, or POA, even some like DAG-based like IOTA. So from your opinion, which one is the most promising direction and why? Because we know that POW is very expensive to do the puzzle. So yeah, thank you.
So basically, I have only my 2 cents on this, but yeah. So we need to view a technology at the point of it is invented, right? So when at the point of like blockchain is invented, like POW is actually a really good algorithm that actually initially the computation power right required is not very big, and it's also gradually increased. The complexity gradually increased. That also makes sense for the kind of like a deflation model of like a Bitcoin. So at that point, that is good. But later we know that some issue like reviewed later, that is people with like great like financial power can collect a lot of kind of like mining power and do this kind of mining competition, and then the mining competition only have one winner, so a lot of like power is wasted. So that's the scenario of like a proof of stake comes that eliminated the power waste. So IMO in this instance, POS is advanced, but it needs to down to a specific scenario. So I read some papers of the build up a blockchain that is for like image recognition or maybe like image detection. So in that blockchain, the computation power, the proof is basically for the nodes to compute a AI problem. And in that sense, that kind of computation, that's also another form of proof of work that also makes sense, right? So the problem of proof of work is we need to have a better kind of like racing or like competition mechanism that eliminates kind of this kind of waste in the racing. So my answer is it really depends on the scenario, but because of like there are small design flaws in the POW doesn't mean that POW itself, I mean the mechanism is bad. It's just we need to like find a good scenario for it and maybe do some like modification to make it better. Yeah.
Okay, let's have one last question. Sema?
Yes, so my question is regarding the decentralization part in cryptocurrencies. So basically in traditional currencies, we observed that from local currencies, we came on to national currencies and then to basically exchange of currencies through networks like SWIFT. So in cryptocurrencies, is there any particular innovations that you might insights into innovation that you might have that prevents centralization? Because we already see that the nodes are getting larger and larger, and there are fewer and fewer nodes basically. So there seems like it is gradually centralizing.
So let me paraphrase your question. So basically, you observe that even we say that decentralization is a characteristics, but you observe more and more like trend of like centralization in such like the network is built. Is that correct? Hello.
Yes,
Okay.
yes.
Okay. So yeah, basically, so I would say maybe I have a different opinion that in blockchain there's always like a kind of like a trade-off between like centralization and the efficiency, right? So nowadays we see like more and more networks are built towards like a little bit more like centralized like Binance Smart Chain, right? So it's basically the same structure but a centralized network. So I won't say there is I won't say which is good, which is bad. It really depends on the scenario. So because at the beginning we have this kind of like education that maybe not education. We have this kind of characteristics of decentralization that already like attract a lot of new users come to the blockchain world. But when it's getting more and more evolved, so we find that when more people come into the network, we need more computation power. So we cannot avoid like the trend of centralization. So I would say certain level of like centralization is needed, and in the next generation of blockchain, maybe like Ethereum 2.0, we see like something similar to this distributed like database, like sharding, right? So it's kind of like a kind of localized localized centrals. It's kind of like more centralized than the original 1.0, but it has a lot of benefit, which is much more faster computation power, much more faster computation and more computation power. So what I mean is that there's always a trade-off. Depends on the specific needs. So if we need a network that is, we don't want any central authority. So decentralization is the first need, then we need it to be decentralized. If we only need a automated computation platform that people have their privacy there. So I mean, a certain level of centralization is okay. Yeah.
Okay, so thank you, Tim. I can see the next speaker is here. And now we don't have time to have a break. Let me introduce the next speaker. So as you know, I'm the director of the multimedia program. In the past few years, among the students in the program, at least, I would say at least 70% of them want to pursue a data scientist career. So why is data science so popular these days? Many of you already have the answer, I suppose, but you will learn more and will be able to share your insights as well in this data science session. After the talk, you have the question period. I'd like to introduce Dr. Marchin Mizianty. Marchin is the VP Data Science at AltaML. He has over a decade of academic and industrial experience covering various research fields. He is a big supporter of our multimedia program. And let us welcome Dr. Marchin Mizianty. I already set you as the co-host.
Perfect. Thank you. Thank you, Irene. And welcome, everyone. For some, I'm assuming good evening, for some good morning, and maybe even good afternoon. Professor Irene created really international event here. Let me share my screen here. This one. Okay. And hopefully everyone can see my presentation now.
Yeah, can see.
Perfect. Okay, so today we'll have a quick introduction to data science. And the title of this presentation is Machine Learning Applied, because in a lot of aspects, data science is seen as machine learning. It's not totally true. There are more to data science, but there is also more to machine learning. It kind of evolved. It went through data science phase, and now it's going back to more rigorous development of applications. So let's start at the beginning. Data science, when did it all start? It's pretty fresh term. The first data science team was actually created 12 years ago at LinkedIn. So at LinkedIn, they had a lot of data from all the people that registered at the social network, and they wanted to analyze it. And there was an employee, Chris Coward, who came in and looked at the data and used some smart algorithms to develop an application that become better than any ads that were displayed at LinkedIn at retaining people. Now, Chris knew through analyzing data, and that was the whole team effort, that LinkedIn needs to, for people to stay at LinkedIn, they need to have at least this many connections. So what they should do is promote as many opportunities to connect with other people as possible, because then people will retain. What does it mean? They will stay with the website and they will not leave. So he created algorithm application that basically was people you may know. And that was very powerful. And then LinkedIn realized that there is some power in the data they have, and they should investigate it and maybe create a team that is focused on that. And then fast forward a few years, the famous article in Harvard Business Review, the sexiest job of the 21st century, meaning the job in most demand. And that was, of course, referring to data science. And you can see Google trend for the search of data science. It all started around that time when that article was published. In 2017, LinkedIn, out of 10 fastest growing job, I think 5 were related to data science. So it is really successful. It has very short history and is winning over the world. But if we think about it, is it really so short history of usage of data? Even in ancient Rome, Romans collected a lot of information about their empire. I guess they like to see what they wanted to analyze what land they have conquered. Then fast forward to 1662, that was the birth of statistics. And the statistics is the field of science about collecting and presenting data about state, so about the country. And the birth of statistics is like attributed to this method of early census methodology. So John Grant and William Petty developed they calculated population of London by knowing how many people died, and then how many people were dying in families, how many people in family there are. So we did a lot of approximation to actually calculate the population of London. And then statistics was growing very fast. In 18th, 19th century, it becomes branch of mathematics, and especially probability theories explored Bayes, Laplace, Gauss. You probably are familiar with those names. And then in 19th, 20th century, we started analyzing small data sets, hypothesis testing, and names like Pearson, Fisher, Neiman are showing up. Well, when I was learning all about it, it really struck me that some things that I took for given were actually pretty recent. Like hypothesis testing is dating into the early 20th century. So not that long time ago. Your grandfathers probably lived in that time, and they were, that was considered a new discovery that pushed, actually was discovered for agriculture, but then swapped across and started being used everywhere. And then we have more recent history, data science, where we actually can analyze more data. So of course, invention of computers enable us to analyze larger quantities of data and doing it faster. It also enabled us to start AI research. In 1962, John Tuckey uses term data analysis, first time ever. And then in 1974, data science is used for the first time by Peter Noer. Peter Noer was a Danish programmer. He hated the term computing science, and he was trying to convince everyone that it should be data science instead. He failed, but this term had its rebirth later on and is becoming more and more popular. In 1999, first knowledge discovery in databases conferences. So again, this is already, we're entering the times where, well, for example, I was already alive, and 1990 to 2005, that's where internet triggers huge increase in data collection and usage. We're also getting something called AI winter, and AI went through a lot of hypes and valleys. So at the beginning, in early 60s, I think, or late 50s, MIT had a great summer intern opportunity for undergrads. They basically ask undergrad intern to develop algorithm that will describe what is seen on the image. We solved it recently. But that was the hype back then, that, oh, we can actually create something that will create, will be able to describe what camera sees. So there was lows and then highs as we discover new algorithms, but then we discovered there is not enough data, and then we had more data, but not enough processing power. So in 90s, there is like huge AI winter. Almost no one is investing in AI. There are few centers in the world that do, and University of Alberta is actually one of them. That's why there is such a strong machine learning program here. And also the problems with scalability. There's more and more data, but there's no really processing power or algorithms to process it. So in 1990, WW, World Wide Web, is invented. 1996, that's when Google is founded. And then in early 2000, there is this notion of data science as we know today, someone who works on the data to extract knowledge. So we have a huge problem. There's a lot of data. We don't know what to do with it, but that cloud computing is invented, and the concept of big data and all the algorithms around it that enables analytics on unprecedented scale. So in 2006, that's the first version of Hadoop. If you are not familiar with Hadoop, that's a system for managing calculations on the distributed file system and the distributed cluster. In 2006, that's the birth of AWS, Amazon Web Services, with only two services, Elastic Compute Cloud, EC2, and Simple Storage Service. So this is to start virtual machines, and Simple Storage Service is for storing the data. And then, as we were talking about, 2008, DJ Patel in LinkedIn and Jeff Hammerbacher from Facebook popularized data scientist job title. And then by 2011, there's already business is interested in that, and mostly in Silicon Valley and the US, they started investing in the data science teams. And then around, I think, 2012, there is this breakthrough of deep learning. All of a sudden, we have enough computing power. We can use GPUs. We have tremendous amount of data, and we're putting a good algorithm to use to analyze it. And Jeff Hinton from Canada proposes his algorithm and wins a very important competition in image recognition. And from here on, everyone is talking about deep learning and starts to explore how great opportunities it creates. For example, in 2015, Google speech recognition experienced dramatic gain in performance and started working pretty much. And then also another field of study in machine learning, reinforcement learning, AlphaGo beats 9-dan Go master in 2016. And in 2019, Alpha beats professional human players in StarCraft 2. So not a lot of people probably know around the world, but this has also been initiated at the University of Alberta. Main contributors to the code were Rich Sutton's student. Rich Sutton is a professor here, who is one of the inventors of the field. And they went to DeepMind to work on those problems of solving the games. And there were so many students going to DeepMind from University of Alberta, but the first international office they opened was actually in Edmonton. And then in 2020, last year, you probably all heard about GPT-3, so the transformer model for NLP that is pretty amazing when it comes to it. It can generate the text that is very comprehensive. There's still some drawbacks. It's still not perfect, but it's a huge advancement of the field in relatively very, very short time. So I showed you all this history, but one of the key points here is also this big data. And sometimes when I ask people if they know what big data is, they telling me, oh, that, of course, that's the data that does not fit into Excel. Well, there's, of course, that volume is really important for that data, but that's not good enough. If you have a large file, but a lot of time, you can take all the time in the world to process it, you can process it. The problem with big data is this velocity, this speed in which data is hitting your servers and you have to respond, you have to analyze it in real time. And then also you have variety of data because you have data from sensors, data, weather data, like multiple different points of data that you have to link, merge together and extract some information. But also because all of this also causes some problems with the data quality. There is incoming string of data is so big that there will be some broken records. There will be some problems that go unnoticed and can cause problems. So your algorithm also must be reliable, or you may have problems where the servers shut down. So all this infrastructure needs to be reliable and be able to process all the incoming information. So these four are known as 4 V's of the big data. And of course, people started inventing more V's. There's like 20, there's a lot of words starting with V and people trying to assign the meaning for that. So it's probably not comprehensive, but this describes big data pretty well. I like to add one more, which maybe not defines big data, but is the reason why we even looking at big data. So the value. That value comes from data science and machine learning, the ability to extract that information and put it to use. So with all this history and dating back to statistics, and I'm trying to say that data science, quoting Business Harvard Review, is a sexy name for statistics. Well, not necessarily. For me, data science is about extracting knowledge from data and using it. So would you call statistics a sexy name for math? I think statisticians would get very offended by that. And for me, it's very similar comparison because there is new techniques applied in data science and pulling that information from big data and ability to handle these huge data streams that statistics was not really designed for. So finding value in data. The hardest part, and that's maybe counterintuitive, but it's to properly define a problem. You have to understand the business you're working with. You have to have knowledge of tools and techniques that you can apply. And you have to be really creative and have a lot of grit, a lot of perseverance. You have to keep going because these ideas will fall as you're giving them to the test of data. But majority of work is to collect, clean, and transform data. And no one will believe me here unless they actually work on the problem. Because often when you go to Kaggle or when you go to other websites that offer data set, that data is pretty clean. The real life data is a mess. It's a terrible mess that takes a lot of time to collect, extract, merge, clean, and understand. So that's vast majority of time is spent on this. So as we're working on that, you will also iterate many, many times. I will show you some definition of a data science process later on. But basically, the idea is that you're coming up with a problem definition, you're getting your data ready, you're running your experiment, and then you actually find out that it doesn't work. So you have to make a lot of steps back and forth to make sure that it's getting better. It's very important, not only here in data science, but in general, to deliver something called MVP, minimum viable product, and to deliver it as soon as possible. What does it mean? It's a smallest possible piece of algorithm that starts generating some value so users can use it. And you can collect feedback and adjust what you are doing and work on the next version that will become better. But as I was saying, you will often stay a step or a few back. If you cannot create a good model, maybe you need to go back to data acquisition stage, process data differently, or maybe you have to go to drawing board and redefine the problem altogether. So what a data scientist needs, and that's a perception from 2008, 2010, a lot of soft skills, business awareness, problem definition, analytical thinking, collaboration. Basically, be able to talk to business, be able to talk to technical teams and also manage that team, be able to sell what they are doing to executives and then perform all the operations. And then, of course, they need statistical background and then some computing science and domain expertise. Without domain expertise, you cannot do much because you wouldn't find these good problems. So pretty much in 2008 to 2000, I think, 13, 14, the idea of data scientists was that it is a unicorn that can code, impossible to find. And the problem is people were looking at it from the wrong perspective. They try to put the whole field of data science into individuals, whereas it's really team sport. It's similar to building any other software. You don't have a single software developer that does everything. On the bigger software applications, you have backend engineers, DevOps, you have front end. you have project managers, you have product managers, you have a lot of people building something. And it's very similar in data science. You're taking engineering, so some software engineers, data engineers, you're getting business analysts that actually can extract knowledge from the business and tell you what is the business use case, how the business operate, how can we attach our models to the business so that they provide value. We have some data wranglers that can actually access the data, shape it, or create some pipelines that will enable them data to be used. And of course, we have science research. So, and a lot of people think that actually data science is just this, just data scientists that do research, do some ML, but it's not that. It's this whole team plus someone to actually manage it, and either manage project or manage product that can actually coordinate all these efforts to build something. So I mentioned machine learning a lot, and some people here, from what I heard from Professor Irene, you should be mostly familiar, but this is a good example. If you're not familiar, you will benefit from this. If you are familiar, this is a great example for you to actually use when describing machine learning to other people. So what is machine learning and how it compares with programming? For me, machine learning is the next level of programming. It's next iteration of programming where we can do things that were not possible before with just programming. So reminder, traditional programming, you're getting data in, you're getting your handcrafted rules called algorithm into the computer, and you're getting some results. In machine learning, you're getting data and past results into the computer, and you create a model. And this computer also has some machine learning algorithm that enables machine to learn on the data and the past results, to create some sort of model that describes the patterns that it sees in data when it comes to connecting the data and the results. And then you have a prediction stage where you're putting new data and that model, which basically replaces the handcrafted rules, into the computer, and you're generating results. Now, there is a key difference here. This is a black box. You don't really, in most cases, you don't really understand how it works. It has a complex mathematical equations that just work and generate results. But these results are not the same. So when we have a traditional programming, any sort of unexpected behavior is called a bug, and we're spending a lot of time on debugging the code and finding what went wrong. When there are unexpected results here, we call them model performance. And actually, the model has 100% accuracy is good, so good. Then we actually starting debugging what have we done wrong, but because it's not, it shouldn't be, the problem shouldn't be that simple that we can create representation of the world. At least we don't have this capacity yet, maybe in future. So something called bug, we now have to live it, is a performance. So basically, when we look at that, why do we use it? If you can create the handcrafted rules, don't bother with machine learning. Just use that. That's proven. We know what to do. Just write the algorithm and use it. But let's consider facial recognition, for example. How will you create those rules? It's pretty hard. You would have to handcraft a lot of rules, write a lot of algorithms to start describing components of the face. Where is the nose? What's the position of eyes? What's the color of the eyes? How to even detect the eyes? That's art in itself. So for a long time, that's kind of a field of traditional computer vision, where a lot of those rules were created to describe to create some features about what is on the picture and then use some machine learning algorithms to generate results. Nowadays with deep learning, we just putting a lot of data, a lot of past results, and then this model is generating those rules, but we cannot comprehend and cannot understand. But they work pretty well. It's not 100% accuracy. It's not perfect. You know what? People are not perfect. When Facebook started competition to compare how expert humans at facial recognition, yes, there are people like that. They're trained to recognize the suspect faces in the court laws, in the law when there is like the some sort of trial in court. There are experts called to recognize if that person is the person standing here. So those people are the best at recognizing faces. They were on par with the deep learning methods. So it is kind of superhuman performance already. And it's not 100% accurate because there are instances in which it's very hard to actually say the face to who it belongs. So in a lot of applications, that's the switch from mentality switch, like, oh no, I have some program, it has to be accurate. No, in machine learning, it does not have to. It still can perform better job than humans do. But then there is a problem because all the models, they learn on the data we provide, and the data is often very skewed. You have an example here on the right where you have false negative rate, and depending on the gender, the false negative rate versus false positive rate is much, much different. And that creates a bias. It creates group fairness. You not treating groups equally. And it creates advantage for one of the genders to actually have more, be recognized as positives when they are not. Also, the problem when maybe there are similar individuals and then all of a sudden a person or individual does not receive the same prediction as the rest. So that's another example of a problem with the fairness and bias in the data. And group bias risk, their allocation, they can cause allocation harms. So when the AI system extends or withholds some opportunities, resources, or information. So the famous example was Amazon created algorithm to find the best people to work for them based on their massive amount of resumes they received in past. And they actually knew that it wouldn't be good to include the gender information, so they removed it. Algorithm learned to recognize gender based on where people worked. So if there was, for example, women chess club, well, lower chances of hiring because guess what? In past, women did not work in tech. So there is not enough samples to actually show that they can, and they're very successful. And another problem is quality of service, where actually system works as well for one person as does for another. Even if no opportunities, resources, or information are extended or withheld. So the problem is that still there may be not the fair treatment to the different people. So this is one of the examples of the risk when you're working with the machine learning and you're working with the data. So when you're developing data, when you're developing machine learning, there are few key differences between machine learning and software development, including these huge potential harms to the society by building the models that are biased, by using the data that has some hidden bias inside. The ML development is exploratory and research in nature. So you don't know what is the final outcome, other than that will be some kind of black box model, but you won't understand. Pretty different from software development, where you actually know what you're building. It's agile, similar to software development, but in my mind, taking it a step further, it has huge error bars on estimates, meaning you cannot really say how long the given step will take. And it's not really linear. Outcome of the task actually dictates next step. In the software development, you know that, oh, if I develop this, then I can develop this. In machine learning, oh, when I do my data analysis, then I know if I should pull more data or actually clean it, or can I go directly to modeling? It's really unknown because it jumps from one place to another very quickly. And main difference is you don't care only about code. You actually care about code, data, and the model. And then you don't only review code. You actually do a lot of exploratory data analysis. You're looking at model performance. You're performing data quality assurance. And that quality assurance is crucial, but lots of it depends on the data. Overfitting, proper experiment setup, looking for biases. I like to joke that machine learning is ultimate test-driven development. You're actually developing something to pass this final test on the validation set, on the data that you did not use for training your model. But it's really very different than the software development. And it's actually not only about machine learning model. So when data scientists or ML developers, that's the new industry trend, there is less data, well, there's still a lot of data scientists, majority of jobs in this field are called that, but it's very hard to say what data scientist job does because a lot of data analytics started calling themselves that. So there's new trend in industry where there are ML developers or ML engineers. So they develop models, but building model is really small part of their job. So this is a survey from Google Cloud where they ask executives like, oh, what is the expectation? What is the effort, most effort? So yeah, you should define some KPIs, you should collect the data, build some infrastructure, and then you're developing the model. And in the end, you're doing like, oh yeah, you're deploying it. Reality is quite different. Data and infrastructure takes a lot of time. Integration is extreme. KPI, in my mind, it would actually take a bit more than what they're showing here. But I quite agree, developing a model is very, very small. But once you do all that and develop the model and deploy it, then you have the problems of data drift, for example. Your model is running on production, but the economy and the situation around in real life changes. So the model loses its performance power. It should actually change how it makes decisions, and it has to be monitored. So there is a new and emerging field of MLOps, where that's both to enable building of the models, as well as easy deploying them and monitoring. So really interesting concept, but since you are the future of the field, I'm just planting that in your minds because we need more people who can do that. Operationalizing machine learning is extremely challenging nowadays. There is not a lot of specialists, and that's one of the jobs of the future, both ML developers and ML ops. So think about it as you're choosing your career. And a few more slides maybe on what are the processes, because you may hear those CRISP DM, for example. So CRISP stands for Cross-Industry Standard Process for Data Mining. That was developed in 1996. And the idea is where you're stating the problem, you have this business understanding, you're designing your experiment, then you're understanding your data through what sources you have, some EDA, then you prepare it to be in the proper format for modeling. When you're modeling that data, then you, of course, started to evaluate it, and then maybe doing some fast deployment and then go back. Well, and once you collect the feedback, but also this CRISP has all the arrows connecting all these squares, rounded rectangles together, so you can go back from modeling to data understanding or even straight to business understanding. So that is a classical process of developing new solutions, but this was a bit old and also did not did not highlight this importance of a deployment. So in case you wonder about it, or you will be asked somewhere, this is a newer process. Microsoft Team Data Science process. Microsoft loves putting teams in front of everything because that's the name of our platform. So you're starting, you have business understanding, and you can see how you can jump to different levels. I don't think you can jump straight from business understanding to modeling without data acquisition, but then after you have the data, you can actually jump back and forth. And you have some interesting steps here on the sides to show what goes into each of the steps. So if you look at it, it's really, really similar, but this maybe highlights it a bit better and highlights this importance of the deployment. That's one of the 4 major steps. And as I said, it's extremely unexplored in the field right now. So this is basically very, very fast introduction to the field. Hopefully I left you with some knowledge, but I also hope you actually have more questions and curiosity to explore this further, and maybe joining Professor Irene's lab, because it's really good. We actually have a lot of graduates from that lab joins us, and they are simply amazing.
Thank you, Marchin. You know, in the last few years, I attended your talk multiple times, right? Each time I get engaged.
Good. I'm trying to change it.
Okay, the audience, if you have question, the raised hand, you can press the raised hand. So, Marchin, how do you see the supply, demand and supply, right? So for students graduated from universities, do you find there's enough supply to fill up the jobs in data science?
So actually the gap between demand and supply is growing, but in pretty good direction for students. There is not enough people on the market to do the job. I think I was just writing a discussion paper for our executive team that explore that subject, so I can throw some statistics. In 2017, LinkedIn estimated 157,000 missing people with the skills for the data science. In 2020, it grew to 250,000 in US alone. Like both those numbers are only in US. There was some barriers to finding job because a lot of those jobs were mostly in US, but companies in Canada are now growing, and across the world, AI companies are growing, but also there is possibility for a remote job. So I wouldn't be worried if you have a ML skills, you're almost guaranteed to find the job. Well, you shouldn't just, oh, I have skills and I don't have to do anything. There is still other skills needed, but there is a lot of need for people with the machine learning knowledge in the market.
So for academia like university, what type of skills do you think should be provided to students so that when they graduate, they can get a data science job?
I think it's very important to provide the opportunity for internships and getting, if students don't want to continue in academia, but find job in the industry, and to start exploring this early and getting some co-op opportunities, somewhere where they can learn from industry. The skills at the university, very important skills are this mindset, and that's hard to teach other than, you're doing math classes now, you're doing all these physics classes that's maybe not related, but they actually put you in the right mindset. And then the knowledge about the tools, knowledge about machine learning, knowledge of how to solve. Other skills that are very valued in industry are around these MLOps and development skills like GitHub, how to use the versioning of the code properly. So a lot of that not often taught at universities, but that's something that people catch up in the industry. But if you have those skills coming out of university, you're more likely to find better job.
So if we look back, a lot of the development in Microsoft tools, right, like spreadsheet and Word and a different type of things. So in the past, a lot of results had to be coded or put some more effort before you could produce. But with all those desktop publishing tool, it seems even if you don't know the basic, you can still generate something. So if I move on to machine learning, the model you mentioned in your talk, these days, even high school students, right? So a lot of pre-trained model like YOLO and Amazon recognition. So if they just prepare the input and get the trained model and then get the output, it seems that they already can do something. So how worried